Hello! So, today we are going to have a little other chat about 42 where I show you how to enforce some kind of strong properties over your code using 42 invariants. I'm not really sure if I should do live coding or just showing the code. So, this time I'm going to try to show you the code. So I have some code to complete here in the comments so I can cut and paste it over. Tell me if you prefer me to actually type it. Don't know, maybe that is, slowing down the explanation in a way that make it more understandable, or maybe slowing down the explanation in a way that make it more boring. You tell me. So, here I have a point class with the number x and number y, and we have a rectangle that contains a point top left and a point bottom right. And then we can have a point in 1010, a point in 2020, and I can make a rectangle with top left equal p0 and bottom right equal p1. And as you can see, I have to always type the name of all of the parameters for all the methods that I'm calling. And while this is a little bit boring while you are writing the code, it's such a blessing when you are reading it. So, if I run this code, I will get a printout like this. Now, let's say that we want to enforce that our points and thus our rectangle are always in a certain area of the screen. What can we do? Well, in 42, we can define invariants. So, we can have a method. You can call it in the way you want, but it's traditionally called invariant. And the method will take in input parameters with the same name of the field of the object, or at least the field of the object that you want to use in the invariant. And then you can write any condition at all here, so that that condition have to always hold for all the points that you can possibly observe. All the points that are somehow involved in the execution will have their invariant respected. And so since this is just a class method with the name you prefer, to activate it as an invariant, you annotate it as cache now. And yes, the invariant have interesting relationship with caching, and we will explore them in the future. And then, well, what we can do, we can write a check by hand where we encode the border, so x have to be between 0 and 100 and y have to be between 0 and 100. And that will work just fine. But maybe we want to make something a little bit more modular. We want to have some place where we store the information on which is the boundary, so that we have a specific place to change it. And it would be tempting to use a rectangle. But using a rectangle will actually be problematic, because this rectangle will have points inside. And so in order to check the invariant of point, we will have to create the rectangle bounding box. But the rectangle bounding box have the points inside. In order to check those points, we have to first create the rectangle bounding box. And so our code will basically go in loop. And this is problematic, and it's an iconic problem that happens when you have code that is sort of self-referential, but you want to enforce strong properties over it. So, a thing that we could do is to have a margin class that we can have here before the point, and the margin will have a number top left x, top left y, bottom right x, and bottom right y. And then we can have a class method margin without name. So here, I can call it margin, but it's so much easier to just leave it empty, because this is like the main method of margin to return the main margin that we're interested in. And Here we can write our margin, so in this case from 0, 0 to 100, 100. And then, well, why not? We can have some method that help us to check if points are into a margin. And again, I have to check in margin X and in margin Y. I can't just check in margin point because I will need to create a point to check if the point is in the margin. But all the points have to already be in the margin, even before they are completely created. So again, if I had an in-margin point method, I could not call it without going a loop if I want to call my in-margin inside the invariant of point itself. And so our invariant method in point may look something like this. And yeah, I don't actually need the parentheses. So we have the x, that in 42 it's the equivalent of assert, and is like representing the sign of stop, forbidden, you know? And so we cannot proceed if margin dot in margin of x and margin to margin, they don't hold. You know, if they hold, we can go on like an assertion. If they don't hold, we cannot proceed. So if I'm running the code right now, I will get my printout because the points are in the margin. If I put the point out of the margin, I don't get anything out. If I look in the errors, I see that L42 terminated with error while performing reduction on main 1. And it's telling me that I have an X error that is a kind of assertion. And there is some failed postcondition, so starting to count from 0, here we have two conditions, the number 0 and the number 1, and so assertion 1 failed, because it's a y that I've put way out of range. So this is a simple way in 42 to enforce strong properties. Also note how I've used cache lazy in front of the empty named method, so that this margin is computed only one time, and every time I call an invariant for the point, this is just accessing the cached margin object, so it's like a field access more than a method call. So this is all for today, and see you next time for more interesting 42 experiments. Bye!